Hello everyone. I just wanted to brief you all about how the course is going to work. I'm going to be posting videos covering all the topics of additional math through the year. So hope this is going to be beneficial for you and makes an impact in your life. So to start off this video, we're going to be discussing sets. This is the very first chapter. However, this is not part of the 2021 and 2022 series of examination. However, knowing more doesn't hurt. So without further ado, let's get on with the video. So the most important thing is, what are sets? Sets are well-defined objects in a group. You may ask, what does well-defined mean? Well-defined is, there are many interpretations for this, but probably the main suitable one is a meaning that conveys all of them have something in common. So the next one is, sets are denoted by any capital letter. So it can be capital A, capital B, capital C, anything. Some examples of sets are curly brackets 1, 2, 3, 4, 5, 6, 7. And also remember, sets are written inside the curly brackets, and there are the elements of the set or whatever is present inside the set is separated by commas. And never use the word and, as even I made the mistake in the start that we would end up using and for the last one, like 1, 2, 3, 4, 5, 6 and 7. Make sure you use comma over there, don't use and. And the next example is 2, 3, 5, 7, 11. Also, plus when you're saying this, you don't have to say curly brackets 2, comma 3. Just say 2, 3, 5, 7, 11. People will understand. The first example is natural numbers from 1 to 7. And the second one is prime numbers from 2 to 11. So the examples I have taken here to start off with are extremely basic. This is not what you usually find when you're doing sets. Okay, so the elements, also known as objects of a set, are denoted by lowercase letters. Okay, more information on the sets. Elements can absolutely be anything, literally anything. For instance, letters, symbols, shapes, etc. You can also make it the grocery list of yours, or anything, whatever you could think of, but they should have something in common. Or also all the books you own, or what are the concepts you know, anything could be a set. And a cardinal number of a set is the number of elements or objects in a set, and it's represented by using n of a. In functions, you usually say n of a when there's a bracket. So even in sets, we do this. An example of using a cardinal number is a equals 1, 2, 3, 4, 5, 6, 7. The cardinal number is 7. As you can see and count that there are 7 elements or objects present in that particular set. And one important thing you should know is the order of the objects in a set does not matter. And also remember, it's only for sets. Don't confuse this with other concepts of math. Okay, moving on. Example of of the order does not matter is that this example shows that 5, 7, 9, 11, 13, 15 is the same as 9, 7, 5, 11, 15, 13. Since they have the same elements, but they aren't in the same order. So that doesn't matter. When you're doing permutations and combinations and other higher concepts in math, you're gonna come to know that the order of the objects in a set does not matter, but only applies to set. It does not apply to anything else. So how do you write a set? There are two types or two ways of writing a set. One is called lister or roster form. It is where you list the elements of a set, like we did in the previous examples, like a equals 2, 3, 5, 7, something, etc. So you will have to list. However, you can't continue writing hundreds and thousands of elements. Therefore, one more was created called list builder form. So the format is x such that, no, actually, the bracket over here signifies all x, and the colon is such that x and is a member that represents is a member next to x and natural numbers. So together it will be all x such that x is a member of all natural of. So this says all x such that x belongs or is a member of natural numbers where 2 is less than x is less than 9. So the elements which fall into this set are 3, 4, 5, 6, 7, and 8. So you can do this for as many sets as you want. Okay, and the final topic is the types of sets. There are many, but I have listed the main ones. The first one is finite set. As you can see, it is a set that has a finite or limited number of objects. So all the examples we have done till now are finite sets. Like a equals 1, 2, 3, 4, 5, 6, 7 is a finite set. And the second is infinite. By the word, you know probably what it means. So it's a set that has an infinite number of objects. For example, let's take an example in roster form. So all x such that x is a member or x belongs to natural numbers. So natural numbers don't end, right? They keep continuing. It starts from 1 and keeps continuing. One more thing is all x such that probably x belongs to real numbers, whole numbers, integers, negative integers, positive integers. All of these come under this category. And the third is singleton set. It is an element that contains only one element. So the cardinal number is equal to 1. Okay, you're gonna come across quite a few of these singleton set. And the fourth one has multiple names, plethora names. So one of them is null set, the other is empty set, one more is void set. So as the name suggests, it's a set that has no element in it, and a symbol is phi. So that symbol is phi. And also, if you see a list that is something similar to what I'm gonna say, a equals curly brackets phi is not a null set. It's a singleton set because there's the symbol phi inside it. Like I told you, even symbols are elements of a set. So therefore, if it's written as curly brackets phi, that's not a null set. If there's only just the symbol phi or just curly bracket, that's only null set. The fifth very important one, and fifth and sixth may be confusing, but hang on. The fifth one is equal set. It's a pair of set that have the same elements. And the sixth one is equivalent set. Is a pair of set that have the same cardinal number. So let's take an example so that it's all clear. Since I told you the order of the set does not matter, equal set could be A equals 1, 2, 3, and B could equal 2, 1, 3. Those are equal set. They're also equivalent set because they have the same cardinal number. Set A's cardinal number is 3 and so is B's. Therefore, every set is an equivalent set, but the converse may not be true. So, because equivalent set, they only have the same cardinal number, not the same elements. So, for example, 1, 2, 3, set A, 1, 2, 3, B equals 4, 5, 6. They have the same cardinal number, but they don't have the same elements present in them. Therefore, every equal set is an equivalent set, but the converse isn't true. So hope this makes this more clear. The last important set is universal set. You're going to be seeing this when you're doing Venn diagrams. In every single Venn diagram, there's a symbol which looks more like an E or the Greek alphabet mu. Mu. So you will be seeing either of those. Or in some of the CBSE books, you can see just U, capital U written. So when we're doing Venn diagrams, we'll see more of that. So the seventh one is universal set. It is a set that has all elements in a set of the topic under consideration. So if I say a set that has for all x such that x is a member of natural numbers, it is all the natural numbers. That is the topic under consideration, natural numbers. Or even there are many examples. They can also be finite universal set, for example, x such that x is a member of natural number where 2 is greater than or equal to x is greater than or equal to 15. So those are the numbers under consideration. Okay, hope this was helpful. We're going to be ending the video here. And we're going to do much more videos, something similar to this. So if you found this beneficial, do subscribe to my channel. There's going to be a lot more content, more beneficial stuff for you, and this will definitely help you in your exams. So if you found this video beneficial, do subscribe and like this video. Leave a comment down below if you have any doubts. I'm always there to help.